Have you ever wondered what the 100th dimension would look like? It's a question that tickles the mind, teetering on the edge of comprehension. Our reality, the world we know and experience every day, is founded on three dimensions: length, width, and height. These are the building blocks of our physical world, the constructs that shape our understanding of space. Now think for a moment about time, often considered the fourth dimension. It's a concept we've grown comfortable with, even if we can't touch it or see it. It's an abstraction, yet it's as real to us as the ground beneath our feet. But what happens when we push beyond these four familiar dimensions? What would the fifth, the 10th, or the 100th dimension look like? It's a realm that seems unthinkable, a reality so far removed from our own that it might as well be science fiction. Imagine, if you will, a being from a two-dimensional world, a flatlander, if you like. This being's universe is a flat plane, with no concept of up or down. Now, imagine a sphere, a three-dimensional object, passing through this two-dimensional world. To the flatlander, the sphere would appear as a circle that grows and then shrinks again, a strange phenomenon that defies their two-dimensional understanding. In much the same way, we, beings of the third dimension, struggle to visualize objects and realities beyond our own. A 100-dimensional object passing through our three-dimensional world wouldn't look like anything we could recognize. It would be a spectacle so complex, so utterly alien to our understanding, that it would defy our three-dimensional intuition. So just as a flatlander can't conceive a sphere, we are like flatlanders, unable to comprehend the reality of a 100-dimensional world. It's a fascinating thought, isn't it? A reminder of how much there is that lies beyond our grasp, waiting to be discovered. An invitation to ponder the unthinkable and to push the boundaries of our understanding. While the human mind struggles to visualize a 100-dimensional space, mathematics provides a means to explore it. The beauty of mathematics is its ability to stretch beyond the confines of our physical world. It's a language that allows us to delve into realms that would otherwise remain out of reach. Now you might be wondering, how can mathematicians possibly deal with something as daunting as a 100-dimensional space? Well, they use equations and abstract concepts as their tools of exploration. They navigate these high-dimensional spaces with the help of numbers and symbols, much like how a sailor navigates the seas with a compass and a map. Take, for instance, the concept of vectors. A vector is essentially a list of numbers. In a three-dimensional space, it would contain three numbers, each representing a coordinate along the length, width, and height. But there's no rule stating a vector can only contain three numbers. It could contain 4, 5, 10, or even 100 numbers, each representing a coordinate in a higher dimensional space. This brings us to one of the most exciting theories in modern physics, the string theory. This theoretical framework, which aims to unify the fundamental forces of nature, proposes that particles exist not just in 3 or 4 dimensions, but in 10 or 11. In this context, the extra dimensions are thought to be curled up so small that they're invisible to us. Imagine a piece of string from afar. It looks one-dimensional, doesn't it? But come closer and you'll see it's actually a three-dimensional object with length, width, and height. The extra dimensions in string theory are thought to be like that, dimensions that are there, but so incredibly small that we can't see them. In the realm of abstract mathematics, high-dimensional spaces aren't something to fear. They're not monsters lurking in the shadows. They're not enigmas wrapped in riddles. They're simply playgrounds waiting to be explored. So in this light, the 100th dimension isn't an insurmountable wall. It's not a boundary that we can't cross. In the realm of abstract mathematics, the 100th dimension is just another playground. The concept of higher dimensions is not just a theoretical exercise, it has practical applications in the world of technology. This is where we begin our journey into the digital realm, where higher dimensions play a pivotal role in making sense of the complex and vast amounts of data we are inundated with every day. In the field of machine learning, algorithms operate in high-dimensional spaces. Now, what does that mean? Picture this. When dealing with data, each feature or variable can be considered a dimension. So, a data set with 100 variables would exist in a 100-dimensional space. This is far beyond our three-dimensional comprehension, but to a machine learning algorithm, it's just another day at the office. These algorithms use these higher dimensions to identify patterns that are impossible to discern in a three-dimensional world. For instance, let's consider a recommendation algorithm on a streaming platform. It's not just looking at one or two variables like genre preference or viewing history, it's analyzing dozens, potentially hundreds of variables, each adding another dimension to the data space. This can include things like the time of day you watch, how often you pause, or even how quickly you binge a series. By operating in this high-dimensional space, the algorithm can discern intricate patterns and make highly personalized recommendations, ensuring that the next show in your queue is one you'll love. This is just one example. High-dimensional spaces are used in everything from natural language processing to computer vision, enhancing our technological capabilities in profound ways. But as we harness the power of these higher dimensions, we also grapple with challenges. The so-called curse of dimensionality refers to the exponential increase in complexity that comes with each additional dimension. This can make computations more difficult and time-consuming, posing an ongoing challenge to computer scientists and mathematicians. In the digital world, the 100th dimension is not an abstract concept, but a tool for understanding complex data. As we continue to push the boundaries of technology, these higher dimensions will undoubtedly play an increasingly integral role in our quest to unlock the mysteries of the data universe. The idea of higher dimensions has long fascinated science fiction writers. From the earliest pulp novels to the latest blockbuster films, the concept of dimensions beyond our three has provided a fertile playground for imaginative storytelling. Consider the trope of hyperspace, a separate dimension where the laws of physics are bent, allowing faster-than-light travel. This concept, while scientifically unlikely, has powered countless stories of interstellar exploration. Then there are multidimensional beings, entities that exist beyond our limited three-dimensional perception. These beings, often depicted as godlike or alien, challenge our understanding of existence itself. They live in realms where our laws of physics don't apply, where time and space are fluid concepts. Parallel universes, another staple of science fiction, are often depicted as existing in higher dimensions, separate from our own but just a thin veil away. These narratives play with the idea of infinite possibilities, of worlds where history took a different turn or where we lead vastly different lives. In all these narratives, the higher dimensions represent the unknown, the mysterious, the realm of infinite possibilities. They are a metaphor for our own limitations, our struggle to understand the vast, complex universe we inhabit. Science fiction doesn't just entertain us with tales of other worlds and strange dimensions. It challenges us to think beyond our everyday experiences, to imagine realities far removed from our own. These stories challenge us to expand our understanding of reality, even if we cannot fully comprehend a 100-dimensional world. The quest to understand the 100th dimension is a journey into the unknown. It's akin to venturing into a vast, uncharted wilderness, armed only with the compass of mathematics and the torch of curiosity. The terrain is treacherous, and the path is not clear-cut. Yet brave explorers of knowledge, our mathematicians and physicists, persist undeterred. Every day they grapple with abstract equations and complex theories, pushing the boundary of human understanding further into this high-dimensional wilderness. They face the daunting task of deciphering the enigmatic language of the universe, written in the form of mathematical equations that hint at higher dimensions. It's a language that's alien to our three-dimensional intuition, yet they strive to translate it, to comprehend it, to unfold its secrets. The challenges are indeed formidable, but the potential rewards are tantalizing. The 100th dimension could hold the key to unifying quantum mechanics and relativity, two of the great pillars of modern physics that seem incompatible. It could provide a new understanding of the fundamental forces of nature, and perhaps even reveal the very fabric of reality itself. While we may never fully conceive a 100-dimensional world, the pursuit itself expands our understanding of reality and opens doors to unimaginable scientific breakthroughs. The journey continues.